Hi everyone. We are This is Math Tony -1 and we are in lesson 5 on reciprocal functions. So we have done absolute value functions and now we're moving on to reciprocal functions. In the book it is only one lesson, but that's not enough. We need 3 lessons to cover it. So today we'll look at the reciprocal functions for linear equation. It will have 2 cases. And tomorrow we can look at the reciprocal function for quadratic. It will have 7 cases, so much more complicated. And then one more lesson to wrap everything up. Okay, all right, so here we go. Now, reciprocal function, you can think of this as a reciprocal function operation on any function. So any function, given any function f of x, you can take the reciprocal of it. It's written in this form. Okay, and we've mentioned it is a vertical change only, a vertical change. It only change the y value. For example, if this is your function, your reciprocal function of that will be this. You just put 1 over it. Now, the notes, okay, this is the linear function. And then like now they will move on to quadratic already. So we will focus on the linear function. For the homework, we'll also only focus on the linear function. So the homework will be very little, but we'll just get you ready for the concept. Okay, so let's go through this example. All right, exploring reciprocal function. Consider this function y equal to x plus 3 is a linear function. So every linear function you will know it has this form where you read the y-intercept, which is 3 in this case, and you read the slope, which is 1. So let's graph it. The graph of f of x is given. So the linear function is a straight line. The y-intercept is at plus 3, okay? And you have a straight line. And if you make a table of values, this is what you're going to get. This one, this table of values. So the y-intercept is here, 0, 3, right? And then where is the x-intercept? The intercept is here, which is -3, 0. So everything is good. Now let's take the reciprocal of this function. What does that mean? It means for every y value, you're going to take the reciprocal of it. So look at the table of values. -3, like we're talking about the y value, the f of x, the y value, now will become -1 over 3. You take the reciprocal. Okay, -3 become -1 over 3. -2 become -1 over 2. -1 become -1 because like 1 over -1 is -1. Well, what will 0 become? Well, you take 1 over 0. 1 over 0 is not allowed. It will be undefined. And then you look at 1, the 1 over 1 is still 1. 1 over 2 is 1 over 2. And then next one, 1 over 3, give you 1 over 3, and so on. All right. So if you now plot all these new y value against the original set of x value, you will get the reciprocal graph over here. It looked like this. Wow, it's so different from the linear graph. All right. So it looks, wow, like how does that become like this? Well, I'm going to show you some features or like give you some point so that you can see this clearly. Okay. First thing is we will graph this point when it is undefined. What does it mean undefined? Which means x do not exist there. So if x do not exist, let's draw a like a boundary, like a forbidden line, like a line that the graph should not exist. So this line is invisible. It doesn't show up in your graphic calculator, but is a line that the graph will not cross because the graph does not supposed to exist there. It's undefined. We call this line an asymptote. Okay, an asymptote spelled like this. It's a vertical asymptote. And then every reciprocal function that you learned this year will also have a horizontal asymptote here. Okay, the horizontal asymptote is always the x-axis, and it has an equation of y equal to 0. Y equal to 0 means x-axis. Now, what is the equation for the vertical asymptote? Okay, if horizontal asymptote is y equal to a number, a vertical asymptote will be x equal to a number. X equal to what number? X equal to across -3. X equal to -3. So basically, it's your x-intercept because it was 0, and now when you take the reciprocal, become undefined. So it's a asymptote. The next point we're going to look at is the plus or minus 1. Why do we look at that? Because they don't change. All right. So you mark it on the graph is here. 1, -1, right? 1, 1, -1, -1 is, oh, well, here is 2, 1, and negative 2, 1, -4, -1. Whenever the original graph hit 1 and -1, all right, it will be, see, these 2 points stay. So since they stay, let's give it a name. So it's so special. Let's call it invariant point. Okay, invariant. It didn't change. Invariant point. Okay. So first you make the asymptote. Next you draw the invariance point. Finally you make a graph. When you take the reciprocal, you see a big number. What does mean big number? Any number bigger than 1 become really small, right? Like if you look at this graph, like for example, on the original graph, 2 become 1 half, 3 become 1/3. So become 1 half, become 1 half, 1/3, 1/4, 1/5, 1/6, 1/7 is approaching 0. That's why you have this tail here. This tail here. However, now the next part is a part that people may not understand. This little bit on the small graph, this little bit, very little. The length is only from 0 to 1. But every point, let's say half of it, let's say at point 5, when you take the reciprocal become 2. 1/3 take the reciprocal become 3. 1/4 take the reciprocal become 4. They'll become big number. So this little bit become this infinitely long tail on this side. Okay, so some of you may wonder, how can this little bit become so long? Okay, well, because you look at, because they are, even though they are this long, but if I ask you how many points are there, your answer is there are infinite many points. Those infinite many points are being mapped to this infinitely long line, which also contain infinite many points. Okay, so this is how the transformation is like. So it would become two curve. Okay, let me summarize it. Okay, so like the book may do it differently. Um, like, okay, well, in here they have some numbers. The y-intercept of the original graph is 3, so therefore the new one is just 1/3. The 0 of the original graph is -3, the x-intercept, so therefore it becomes a vertical asymptote at -3. Okay, the coordinate, the 2 points that both appear on the graph are called the invariance point, which is when they both equal to plus or minus 1. When the y is equal to plus or minus 1. Finally, the horizontal asymptote is always at the x-intercept. Okay, so let me summarize it here. I won't put it here. I'll put it in my homework. So let's skip all that because that's for tomorrow. Okay, so let's go to the first homework question. Here, I will summarize it how to make reciprocal function. I pick homework question number 1. I picked this question number 1 to finish the notes because it has two cases here. It cover both cases for linear function. Linear function can only have two cases. One is positive slope and negative slope. And then you draw its corresponding reciprocal function. The question asks you to, given the function, they are both linear, graph the reciprocal function. How do you do that? Let me tell you. Number 1, first step, graph the 0, become asymptote. Okay? So where are the 0? The zeros are here. The zeros are here. I'm dealing with two functions I do in parallel, so you see. So let's make it a vertical asymptotes. At the same time, let's draw the horizontal asymptote as well. So this is one graph, this is the second graph. This is how the reciprocal function will look like. This is what you're learning. You're learning what is a reciprocal function will look like. Okay, number two, invariance point. Invariance point plus or minus 1. Okay, now in this example, they give you two guides. The y equal to 1, y equal to negative 1 tell you when the function y equal to 1 and negative 1, where do they equal to 1 and negative 1? They draw an invisible line for you, well, you can see it, and then it's help you to visualize it. In the other graph, they won't draw you those lines. You need to visualize those lines yourself, just at 1 and negative 1, and where do they cross? They cross here, and they cross here. On this graph, they cross here and then they cross here. These are your invariant point. Finally, number three, draw the curve. How do you draw the curve? Do you remember this little bit become very big? Oops. And then the any number of the original graph when it's go high become very low. Basically, you use the asymptote as your guide. You draw a curve that approach the asymptote, cross this invariant point, and approach the other asymptote. And then same here. This you have this asymptote, all right, cross this and then go over here. The asymptote divide your whole plane into four quadrants. The other two quadrants has nothing there, nothing there, nothing here. Four region. The region that has your invariance point is where you want to join the dots. Okay, same here. I will draw the curve this way. You just need to sketch it. You don't need to be very accurate. The only accurate point you need is to cross the invariance point. The rest is fine. So that's it. Okay. So this is the case, two cases for linear function. It's either this way or the other way. If you put in a graphic calculator, this is what you will see. I'll just help you to see it. You draw it using three steps. The zero become asymptote. You mark the invariance point, and then you draw the two curve that approaches the asymptotes. And this is the reciprocal function. This is for the linear case. Is okay so far, easy, two cases. But as I say, for quadratic function, there will be 7 cases. Okay, so that will be tomorrow. See you everyone. Bye bye.